Imagine standing on the deck of a ship at midnight, rain coming down, while a crane lowers a standard shipping container onto the deck. Except this container glows with a radiation symbol. It is a fully self-contained, transportable nuclear microreactor. The target for this hardware is the offshore support vessel, a critical workhorse of the energy industry. These ships execute a maneuver called dynamic positioning. This means holding the vessel perfectly still over one exact GPS coordinate, constantly fighting against unpredictable ocean currents, wind, and waves. To maintain that exact position against the physical force of the ocean, the ship's thrusters have to run continuously, burning through massive volumes of diesel fuel every minute of the day. Because of this continuous burn, diesel fuel accounts for the single largest operating expense on the balance sheet, and it creates the bulk of the offshore industry's carbon emissions. In August 2026, Deployable Energy and Hornbeck Offshore signed an agreement to solve this diesel problem. Their plan centers on the Unity nuclear battery. It's a mass-manufactured 1 megawatt electrical microreactor designed to run for over 5 years before it ever needs refueling. Historically, putting a nuclear reactor on a ship meant engineering the entire hull around a massive permanent core. Deployable Energy is attempting the opposite, building a drop-in power source engineered to fit onto existing commercial decks. The companies formed a joint working group to pursue 5 maritime markets, targeting offshore vessels, along inland waterways, floating power barges, national security logistics, and floating data centers. If they can successfully integrate these units across commercial fleets, the companies project a 20% reduction in the total cost of ownership compared to conventional marine diesel. It is a compelling pitch. But when you look at the raw electrical engineering required to run a ship, the math gets complicated. Let's look at the electrical requirements. This bar chart shows the 1 megawatt of power the Unity unit produces. On a commercial vessel, 1 megawatt is essentially just the hotel load for auxiliary power. Let's expand the chart for dynamic positioning. That requires 5 to 15 megawatts. A 1 megawatt unit is severely underpowered. A single Unity reactor cannot generate nearly enough thrust to push a heavy ship through the water or fight a volatile sea state. Unless a vessel operator installs multiple units on a single deck, the microreactor acts as a baseline power contributor. It cannot completely replace the diesel engines. Even if we solve the total power output, we run into a second engineering flaw, the clash between nuclear technology and ocean physics. This line graph illustrates a nuclear reactor providing a steady, flat supply of power. But dynamic positioning creates a transient load. When a wave hits, thrusters demand a massive power spike. The steady reactor baseline violently clashes with these sudden demands. To bridge that gap, marine architects still have to install large-scale energy storage systems or keep those conventional diesel generators running in the background just to handle the sudden power spikes. Dropping a steady-state reactor into a highly volatile environment introduces a severe power systems architecture problem, one that the initial Memorandum of Understanding entirely glosses over. Yet the physical engineering might be the easiest hurdle to clear, because the ultimate barrier is maritime law. The document signed by these two companies is a Memorandum of Understanding. It isn't a finalized order, because right now neither company has the legal right to actually execute this plan. Placing a commercial nuclear reactor on a civilian vessel requires a completely new rulebook. It demands alignment between the nuclear regulator, international classification societies, and the United States Coast Guard. As it stands today, the regulatory pathway to license and operate a private floating microreactor in U.S. waters is entirely blank. That 20% reduction in total cost of ownership is a theoretical target for a future decade, not a demonstrated financial reality. The hardware itself might soon be ready to drop onto a commercial deck, but the sheer weight of federal bureaucracy guarantees this maritime revolution is still years away from turning on.